Okay, we are ready to do some problem solving. The first problem is about a metal known as tantalum, element number 79. At low temperature, it behaves as a superconductor. They used X-ray of wavelength 154 picometers at an incident angle of 13.49. The first question is, what is the distance between each layer of this crystal? So they're looking for distance d, which each side is equal to d for this cube. And finally, they also want you to calculate the density of tantalum. One other very important piece of information is its body-centered cubic cell, and we see why it's vital in our calculation. So I'm going to use Bragg equation first. Remember, it's given to you in data booklet. N times lambda is equal to 2d sine of theta. Now lambda, we are going to convert it to centimeters first, so it's 154 picometer times 10 to minus 10, so it is equal to 154 times 10 to minus 10 centimeter. Now let's just rearrange. So I'm looking for side d in centimeter. It's equal to n lambda divided by 2 sine theta. Now remember, in IB we use n equal 1. It's a first order diffraction. So I only need lambda in my numerator, 154 times 10 to minus 10 centimeters divided by 2 sine 13.49. And when you plug that in your calculator, you should get 330 times 10 to minus 10 centimeter. So each side is equal to 330 times 10 to minus 10 centimeter. Now there is another d, which is for density. Don't get it confused. It's mass divided by volume. So let's just first find volume of the cube, which is the easiest. Of the cube is simply side times side times side, which is d cubed. So let's just plug it into your calculators, the entire thing to be cubed. So when you do that, you will get 3.59 times 10 to minus 23 centimeter cube. Now we need to go after the mass calculation. Now let's see, why is this so vital, that it's body-centered cube. Remember that within this cube, now you have two atoms. In each corner you have 1/8 of an atom being shared inside. You also have 1, 2, 3, the last one is in the back, so you have 8 times 1/8 of an atom on corners being shared, plus one entire atom which is trapped in, plus another one. So this is 2 atoms per cube, and that's important. So your mass should be multiplied by 2. So I have 2 atoms of tantalum. Now I'm going to use dimensional analysis. You can simply use a couple of ratios. Remember Avogadro's number, 6.02 times 10 to the power 23 atoms of anything, in this case tantalum, is equal to 1 mole times. Now if you look up molar mass of tantalum, element number 79, it's 180.95 grams. So that's the molar mass. So 1 mole of tantalum is 180.95 grams tantalum from your periodic table. So the last thing you're left is with a mass of 2 atoms of tantalum, which happens to be 3.01 times 10 to minus 22 grams. So I have my mass, I have my volume. Let's just now calculate the ratio. And if I did my calculations correctly, I get 16.8 grams per centimeter cube for density of tantalum. So that's one typical problem. Now let's go to the second problem, which is similar to this and in a way easier. In this question, we are talking about silver. When it crystallizes, it's going to form face-centered cube. Now we are going to also use this piece of information, which is vital. Now the unit cell this time are given to us. So the Bragg equation was used, and this time we don't have to do further calculation. So D, the sides of each of this cube, is given to be equal to 408.7 picometers. So life is easier. So now let's just, they want us to calculate density of silver. Density of anything, in this case silver, is mass of silver divided by the volume of silver. In this case, the volume of the cube and then the mass within this cube. So the volume of a cube is, remember, side times side times side. It's simply equal to 408.7. I'm going to convert it to centimeters before I cube it. And when I do this, I'm going to get 6.83 times 10 to minus 23 centimeter cube. Now the mass, we have to slow down 1 second and decide how many atoms we have inside this cube. Now this is a face-centered. You have 1, 2, 3, 4, 5, 6, and 2 more in the back. So you have 8 corners. Each corner has 1/8 of an atom trapped in, plus. Now you also have 1, 2, 3, 4, 5, 6 faces that are sharing half of an atom inside. So in the case of face-centered cube, you have 4 atoms within each cube. So now my mass should be multiplied by 4, so I start with that. 4 atoms of silver. I'm going to convert it to moles first. 6.02 times 10 to the power 23 atoms equals 1 mole silver. Then I'm going to look up molar mass of silver on the periodic table. 1 mole of silver is 107.9 grams. I stop, cancel like units. I'm left with grams. So when I do this multiplying, I have to do it. So 4 times 107.9 divided by 6.02. And I get 7.17 times 10 to minus 22 grams. I have my mass, I have my volume. Density is simply mass divided by volume. So it's 6.83 times 10 to minus 20. Oh, sorry. Let me just. So it is 7.17 times 10 to minus 22 grams divided by 6.83 times 10 to minus 23 centimeter cube. And I get 10.5 grams per centimeter cube for density of silver.